Thank you. And I thank Professor Chanesh and the college team which is hosting such a wonderful program. And I thank them for giving me an opportunity to share some of my thoughts on mathematics. Okay. And let me tell you, I'm a very informal speaker. Okay. I don't think you want to listen to too many theorems, lemma, proofs and all. I don't want to tell that either. So let's both talk together and not together. Of course, I'll give you time to talk together also. There will be some problems which I want you to solve. I would like you to do it. So it's 11:10. So whenever you tell, I'll stop. So till then, okay. So before I start, I want to know what is mathematics? Something. What is mathematics? Yes? Louder. I can't hear. What is mathematics?
Language of science.
Yes?
Language of science.
Language of science. Yeah, that's like, you are giving too much of sort of technical answer. Then I have to maybe I have to understand science. Then I have to ask you what is science. Deals with study of numbers. Mathematics. Mathematics is study of numbers. Mathematics is language of science. Why should we do it? Why should we do mathematics? You've been doing for the last 10-12 years, man. Now don't tell me you don't know why you have to do mathematics. Okay, let me ask, why are you doing mathematics? Louder. Why are you doing mathematics? Yeah, that's a very honest answer.
Exams.
Because sir, it is there. My teacher has told me to do it, I am doing it. That's a very honest answer. I agree with that. But there must be something more than that, no? Louder.
Application is like.
Can you tell me some application? Addition, subtraction, multiplication. Can you give me a specific example? I don't like, I'm basically a mathematician, I need examples. You have to tell me, okay, this is where I use mathematics. For example, you are giving me more subjects, I'm getting scared. Give me an example. You think I am your grandfather, and how will you explain what is the importance of it? If you say trigonometry, I get a heart attack. Tell me, what is it in maths you have used? Something explicitly you have to tell me, this is why mathematics I am doing.
For measuring some distance.
What distance have you measured since morning today? No, don't worry, I am not trying to put you down. I want a lively discussion. I want to know why was everybody doing what mathematics? And that is the second question. Why are you doing the first question? Have you measured anything since morning? Yesterday? Last week? Then why are you doing maths? You can sit and talk, no problem. And all of you, it's not only him, all of you are doing maths, no? I'm asking why. Give me an example. Excellent. So what you are telling me, okay, I know what he is telling. I go to shop, I will buy some soap, I will buy some cotton soap, I will buy some this and that, I will give 100 rupees and you give me change, correct? Now tell me frankly, to do that kind of mathematics, do you need to wear this kind of uniform? Do you need to carry such thick books? Do you need such a huge college? Then you are cheating yourself. Then you are cheating yourself, correct? To do that, in fact, most people who do that kind of mathematics will not have gone to school only. You've been studying so much curriculum, so many things you want to do to buy some cotton soap. Tell me. It's very sort of anti-climax, no? So can you tell me something more?
With the shopkeeper with a percent discount.
That's what I'm telling you. They are all, most of the shopkeepers will not have gone through 12 years of education. You don't need such a huge infrastructure from the government, from the private enterprise, from your parents, from so many people to learn that kind of mathematics. I'm sure you don't need calculus to do that. And as you gave me half the time, you don't need innovative to do that. Correct? You think that Bhattaprisapova lady will know what is sine of 30? No, but she leads her life. Correct? So that is not a, I mean at your age, your stage, you shouldn't tell me I need to buy soap so I need to know mathematics. You should be telling something more. Partly yes, but most people who invest actually in shares will again not have gone through this kind of mathematical training.
Kind of buildings.
Okay, let me try to ask a slightly different question. For example, why are you doing mathematics? Why is mathematics done at all?
To solve the problems of physics.
Example, I don't like textbook answers. I want you to give me example. Look here, this is the problem and this is, to solve this problem I need mathematics. Are you very happy? Yes.
In our daily applications, which we
Give me an example.
for construction, an engineer needs.
Correct. So that is one place where mathematics is sort of hidden. It is there. If you want to build such a building, then you need mathematics. Of course, you build a building to teach mathematics. It's a sort of to build a building, I need mathematics. And why do I build buildings? Because I want to teach mathematics. That's a sort of funny kind of thing. But anyway, buildings are not built only to teach mathematics. That's built to do many other things also. So that is one place where I think mathematics is definitely there. But again, I don't know, all this so advanced mathematics is required in building. Buildings have been being built for a long time. Isn't it? Then what is it that I have to learn now in mathematics? I will very quickly try to tell you one very deep application of mathematics. Very deep. First, what you told is approximately correct, measuring. That is the first motivation of doing mathematics. I want to measure things. Measure, he told distances. Unfortunately, he has actually measured distance. Even today he has measured. He didn't know he has measured. For example, he has an estimate of how much time it takes to come from his home to here, no? That means he knows the distance. He may not have measured today, but someday he has measured and he has used that today. Correct? So, measuring is one of the most important motivations for doing mathematics. Measuring what becomes the second question. Measuring distances, measuring areas, measuring volumes, even more important.
Time.
Most important, measuring time. So one of the fundamental aspects of mankind. We want to measure time. All creatures measure time. For example, a tree knows when to put flowers, tree knows when it should give fruits, a plant knows when it should leave its roots. All those things, they are all measuring time in some sense. But we need measurement very accurately. Why we need to measure accurately time? Why do we need to measure time? Can you tell me that? Why do we need? Where is the need to measure time? Yeah, looks like two fundamental questions. Okay, let me tell you. Transport yourself back to 20,000 years ago, where there was no February 28th, no January 31st, or no concept of calendar yet. The first thing human beings wanted to, or not first thing, one of the things we wanted to do was to see the seasons. When I mean, given sufficient time, I would have got all the answers from you. but I don't have so much time, so I will short circuit. When human beings came from their hunter-gatherer mode to start settling down at a place, a small hamlet, a village, a town, a city, a kingdom, an empire, a civilization, when we have to settle at one place, settling is possible only when I grow a lot of food. Correct? Otherwise, all of you who all your life you have not grown food, but you have been eating food. Correct? Somebody must be growing food, no? But in your hunter-gatherer mode, this is a luxury. You wouldn't have been able to do this because every day you have to go hunt your food first or gather your food. Correct? So there must have been a process when suddenly, if not suddenly, gradually there was a increased food production. How do you do increased food production? By agriculture. How do you do agriculture? When do you do agriculture? Oh, it has to rain. Oh, I have to measure time. When does it rain? Where should I do? You have to measure land. There are so many aspects in this. Making of calendar is one of the fundamental achievements of mankind. It requires very fine calculations. I won't go into details of that. Somebody had to observe star positions. For example, to make calendar, firstly somebody had to recognize, somebody has to observe that every 365 days things are more or less the same. You understand this? Why things are same every 365 days? Because sun is here, earth is here. Once in 365 days, earth comes back to the same place, wherever it is, after approximately 365 days it comes back. Correct? Then what happens? I don't know, Akash might have already told you many things, but I'll just tell you for the sake of completion. Look at this model. There is sun here, there is earth here, okay? And earth is rotating around its axis and also revolving around sun, correct? You know happening of day and night, correct? So when sun is here and I am here. So if I am sitting here, it is, what time of the day is it? 12 o'clock in the afternoon. And here? Here, when I am at this, sun is here, earth is going round. When I am here, 12 o'clock. When I am here, when I am here, when I am here, midnight and early morning, correct? Then what happens? I can see stars everywhere, no? There are stars there, not I can see. Stars are there everywhere. Sun is here, earth is here. When I come here early morning, and because of sunlight, I can't see any stars. But as I go like this, evening, I start seeing all these stars. Whole night I see all these stars. You understand what are these I am saying? But after 6 months, when I come that side of the diametrically opposite point, I start seeing this side of the star, this side stars, correct? Every 365 days, I see exactly same stars in the same position, correct? That is how people realize, aha, everything is controlled by some supernatural, because they all look the same after every 365 days. So what I am trying to impress upon you is measurement of time was very fundamental. They had to do this, astronomy, trigonometry, they are all there. Roots of mathematics is extremely organic. So here what happened is, somebody had to observe that after every 365 days, the stars look the same. Somebody had to observe. This is despite all the disturbance of various other planets and moon, all those things inside masala is happening. But we have to recognize that these stars are sort of fixed. Sort of fixed. So following what I am saying, is it too complicated? Please feel free to ask. So somebody had to observe patterns. Watching stars means what? You have to make out patterns in the stars and try to, otherwise all stars look the same, individual stars, correct? So they have to look at the patterns. Keep track of it. Deduce. that every once in 365 days it comes to the same thing. Then you have to deduce once in 365 days it's going to flood here. Because it's going to rain heavily, so there will be flooding. So I have to go away from flooding so that I can come back and do my agriculture. Because when the flooding happens, if I am there, I am no more there to next year to do agriculture. So I have to go away. So all this observation, prediction, deduction, this is what mathematics is all about. And justification. You have to justify. ಸುಮ್ಮನೆ ಯಾವಾಗ ಡಿಸೆಂಬರ್ ಮಳೆ ಬರುತ್ತೆ ಅಂದ್ಬಿಟ್ರೆ ಪ್ರತಿ ವರ್ಷ ಡಿಸೆಂಬರ್ ಮಳೆ ಬರುತ್ತೆ ಅಂತಂದ್ರೆ ನಂಬದೇ ಇಲ್ಲ ಯಾರು ಆಮೇಲೆ ಯಾಕಂದ್ರೆ ಡಿಸೆಂಬರ್ ಮಳೆ ಬರೋದೇ ಇಲ್ಲ ಅಲ್ವಾ. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ಜಸ್ಟಿಫೈ ಯುವರ್ ಪ್ರೆಡಿಕ್ಷನ್ಸ್. Mathematics is, this is the game of mathematics. Mathematics is not just about daily life calculation. That is okay. The fundamental aspect of mathematics is observation, deduction, patterns, symmetry, justification, prediction. Prediction comes before justification. You have to predict what's going to happen next. That is where you get your money. Correct? Some days it was Jyotishya, nowadays it is something else. Stock shares. Correct? These are the fundamental aspects of mathematics. Making of calendar is a fantastic example of mathematics. There are so many elements of mathematics in that. But to tell a child, and remember, those societies, those civilizations which could make calendar could progress. Those which did not do it, they got subsumed. They became part of other people, other societies which made calendar, and because of calendar, they had agricultural cycle, they had excess food, they built cities, they built kingdoms, they built empires, they built civilizations, they built huge military, they could attack others. Man is basically an aggressive animal. Correct? All this science was used for my benefit. My doesn't mean only my body, my people, my family, my road, my community, my city. You understand what I am trying to say? With the same hope that my community will do better, these things are taught to you. Not because somebody wants to leave your head asking what is sign of A plus B. No, that's not why it is being taught. It's being taught because people have realized there is a way of improving our quality of life by doing science, by doing mathematics. That is why experts have decided these are the things which you must study so that next generation people, it's your life, to make it better, is why all these things are being done. Am I making sense? Yeah? That is why everybody does mathematics. Because you want to better your life. You want to have a better quality of life. My only appeal is, in this process, don't think of only my family, my road, my thing. Think of all creatures of the earth. They are all part of our family. So whenever you do serious science, technology, think about it a bit. Think about it for a few minutes and then only take appropriate decisions. Anyway, that's a different kind of story. But continuing my story, so this mathematics is about all this what I told you. Observation, deduction, prediction, justification, all these things. But it's a pretty complicated thing to do. I mean, to explain calendar to even to explain to a high school child is difficult. For primary school children, it's very difficult for me to explain that concept. So what they do is, they break up all these deduction, prediction, symmetry, justification, all these things into various parts. And teach you only how to justify, how to predict, how to see symmetry, how to see pattern. They are all separated out. Actually, there is a grand vision, but each of them is separated out and told in an easy way. You understand? So many of the examples will be very artificial. I can't tell you, look at the sky and see all the patterns and report back to me. I can't tell you that. Before that, I will tell you, what is the square, what is the triangle, what is the circle, what is the parabola, what is the ellipse. Oh, there you can see an ellipse. Oh, here you can see a triangle. Correct? You understand? So I have to break it up into smaller units and give it to you more palatable. Correct? So school school mathematics teaching is essentially trying to make this large body into small palatable parts. Okay? So that is what I will do here also now. What I will do is, I will break up these big problems into small problems and try to tell you this is what is interesting for me in mathematics. Okay? I can't talk too much about application. For example, this is a great application of mathematics. None of you told me. I thought at least somebody will tell me. No, you just listen to Akash. Satellites are, without satellites, it just looks like we can't live for even 5 minutes. Correct? So there is a lot of mathematics in sending a satellite, and how is that satellite will always be looking at me only. Why am I so important? Correct? There are lots of problems, questions in this. So I won't go into all those details. Instead, I'll try to give you a flavor of this prediction, deduction, and things like that. Is that okay? Is it agreed? Do you understand what I'm trying to tell? Okay. So I have, it just so happens that I have come to this earth few years earlier than you. So because of which I have some experience in this. So I have collected a few problems. None of them are original. These are problems which I have collected, which I felt children like to do these things. Again, let me warn you, it's not that everybody likes all this. We don't want everybody liking only mathematics. We want people to do different things. Correct? So that if you like these things, then your mind is inclined towards doing mathematics. If you don't like this, there is no harm. Don't take up mathematics, that's all. It's not good for you, it's not good for mathematics also. Okay, so just keep that in mind. There is nothing wrong in not liking it. I am not telling I will make mathematics very exciting and all of you will become top class mathematicians. No, that's not the hope. This is more a guide for you to see. If you like these kind of things, then you will enjoy doing mathematics. And you can contribute positively to mathematics. That is my wish. Okay? So I will give you few. So what I will do is, I will ask a few questions. Let us see how we can solve. If you enjoy solving them, then you will be wanting to do it. Okay? And I have, in this lecture, I have not chosen problems which are very hard and it requires a lot of mathematical knowledge, prior knowledge. I don't want that. Okay? So, only one sharat, one condition. If you know the problem already, if lot of you know, we can skip that problem. If only one or two already know the problem, please don't tell the solution in the beginning. Because the idea is that everybody must participate in solving. Okay? Do you understand? None of these are very standard questions. Don't worry. None of these are very rare questions. These are all standard questions. So if you have already heard about it, let's go quickly on to the next one. Okay? So all this I have already explained. So these are all the. Don't worry, this slide will be here. This is the first thing which I want to do. This is normally the first problem I deal with. I talk to with all students. So let us try to solve this. So it is only guidelines. You will not find much there. You will have to see what I am doing. Okay. First, let me ask. Because if you know it, then I don't have to spend time. Do you know chess? Yes. Don't worry. You don't have to know the game of chess. Have you seen a chess board? Yes. How many squares are there? 64? Okay. Then you will have to follow what I am asking. How many squares do you see? Sure? I may not draw very neatly, but we all understand. That is part of mathematics, abstraction. What I draw is something, it's not actually a square, but we all agree it's a square, correct? So mathematics is also about idealization, abstraction. It's a very important thing. If you show it a 1 year old kid and it's not 1 year old class, one student you say it's a square, you say no, this is sort of. It will say that, but you will not say that. Why? You have that maturity now. It's okay, this guy can't write a straight line, it's okay. He's telling me about it. Right? You understand? That comes only with experience. First day I will not agree with it. Correct? Okay. So we will make this kind of ideology. Now watch what I do. The same square, I made another copy of it. Now what I will, I don't, what I am doing is very simple, but I will use a reasonably complicated set of instructions to do this because of some reason. So just follow what I am doing. What I will do is, how many sides are there for this square? 4. Each side, I will break it up into 2 equal parts. Do you understand what it means? Each get midpoint. So how many midpoints will I get? 4. Well, of course, there is a geometric way of doing it. I won't bother about it. Roughly, this is the midpoint. Now, I have 4 new points. I will join these 4 new points in such a way that any new line segment I draw must be parallel to one of the original 4 sides. That means I can join these two because this is parallel to this side. Correct? I can join these two because this is parallel to this. I can't join this because it is not parallel to any of the original sides. Do you understand this? Of course, I would have told you, break it up into 4 parts. We would have done the same thing. Correct? But I purposely want to use this complicated language. What is the language? Each side I break it up into 2 equal parts and then join the sides, join the new points in such a way that every new side is parallel to one of the original sides. Is that clear? Now, how many squares can you see here? 5. Sure? No democracy. You see 5? Mathematics doesn't work for democracy or opinions. You have to justify. You have to predict, you have to justify. 5, how do you know 5? I can count. 1, 2, 3, 4. You see how my language is changing. When I tell you square number 1, I will just show you one side. You know I am talking about this square. Correct? This, and this. You understand? Correct? Somebody did tell me 4, right? Someone in this class told me 4, right? After some time he or she realized there are 5, correct? Now how do I know if I wait for another minute you will not change it to 6? How do I know? How do you know there are only 5? How do I know there isn't a 6th one? Louder. You can't tell me, show me the 6th one. Because I didn't tell there are 6. You told me there are 5. I am telling you, justify your answer. How do you know there are only 5? You can show me 5, doesn't mean there are only 5. I can show 2 boys, doesn't mean there are only 2 boys in this class. I can show 2 boys. Doesn't mean there are only 2, right? Here you can show me 5 squares, doesn't mean there are only 5. How do you know there isn't a 6th one? Pardon? No, not that. In this, thank you. This is different. In this, how do I know there are only 5? Yeah, there are only 2 boys. I can count 1, 2. There is a problem. Correct? Mathematics, as I told you, is about justifying. Okay? Okay. Justifying part is always a bit painful. As you can see, clear it's a valid question. Okay? But it takes some experience to realize that you need proofs. I will try to tell you proof in due course of time. Just follow another next construction. I will prove that there are only 5. There isn't a 6th one. Give me a few minutes. So, try to follow what I am doing. It's the same square. I have drawn one big square. Previously, I broke up each side into 2 equal parts. Instead of that, I will break it up into 3 equal parts. I can break it up into 3 equal parts by drawing 2 points appropriately. Correct? And now again I do the same construction. What's the construction? I join the new lines so that many squares can you see here?
14, sir.
14.
14.
Now do you see the problem? How do I know if I don't wait for, if I wait for some time, you will not tell me 15? You understand the need for proof? Yeah? Unless I prove, how do you know? Yeah, I understand. All of you can show me 14. Here it is. I will show 14. Watch how I show 14. I will count this 14. There are, first, then again, I will appeal to your intuition and your maturity. Primary or middle school class, I would have taken some more time and got the answer from you. But now you know it and I don't have too much time. So I will short circuit. Okay? That's a bad thing to do in maths because I am not letting you explore. But I will leave you questions for which I hope you will explore later. How I will see there are three types of squares here. One is 1 by 1 square, another is 2 by 2 square, another is 3 by 3 square. Correct? There cannot be a 4 by 4 square. Why? Because any line segment, no line segment is longer than 3. I have proved there cannot be a 4 by 4 square in this, or n by n where n is greater than 3. Correct? It has to be 1 or 2 or 3. Now let me count 1 by 1 squares. Okay? Don't tell me 9. I will tell you how to count it. Okay? You see, I will start, always maths you must start methodically. Start from the easiest, smallest, best. This is 1. I will start with 1 by 1 squares on this bottom line. Correct? How many squares are there? 1. 3 squares are there on the bottom line. Correct? Do you understand this? 1, 2, 3. Correct? Sure? Now, how many such lines are there which will give me 3 squares on each of them? 3. You will not tell 4. Even though this is also a line, you know by convention that this square I have already counted here. I always count square above the line segment which I see. See, these are all unsaid things. We are meeting each other the first time in our lives, but we will not make these mistakes. You understand? That's because both of us are studying mathematics. We know what we are talking about, even though we are not being very precise. You understand? That is a skill, mathematical skill. So there are 3 lines. 1 line, 2 line, 3rd line. 3 lines with 3 squares each, 1 by 1. So 1 by 1, how many squares are there? 3 lines with 3 squares. So I have 3 into 3 which is 9. I will not write like this. I will write slightly differently. I will write 3 squares. Is that okay? Is that okay? You know this notation, right? Now let us count 2 by 2 squares. How many are there? Same method I will use. 4. I will say 2 square. How did I get 2 square? There is, on the bottom line there is 1 and a 2. You see, this is a proof. There is no other line, length segment. There is no segment of length 2 on the bottom line, apart from this and this. Correct? You see that? You see, we have never told. What about this, sir? Yeah, that is a length of line segment 2, but this is not a segment under consideration because the end points will have to be at one of the vertices. Correct? All this I never told you, but we sort of assume, yeah, to do that. Correct? Sure, that is because both of us have studied mathematics for sufficiently long number of years. So 1, 2. Like this, how many lines are there?
2.
Only 2 lines are there. This line and this line. This line is not, there is no 2 by 2 squares on that. Correct? So I have 2 by 2, I have 2 squares. And 3 by 3? Only 1 square. Now you see, you never said 1 square for 1, but you are taking 1 square. Correct? Correct? That's because you have seen a pattern there. Same thing here, 1 square plus 2 square. That's all you got 5. Right? Did you understand what I am saying? This is the proof that there are only 14 here. This addition anybody can do, we will not do that. Full mathematics. 1 plus 4 plus 9. Right? Sure? You understood this? Now can you answer this question? What is the next question? Yeah, we'll make 4 parts. How to make 4 parts? Break up each part into each side into 4 equal parts and join lines so that they are parallel to one of the original things. Can you tell me how many squares are there here?
30.
Yeah. The thing is, if you say 30, then I have to do some work to find out whether it is 30 square. 30. Easier thing for you to tell is 1 square plus 2 square plus 3 square plus 4 square. We all agree we know how to compute 4 square. We all agree we know how to compute 3 square. We all agree we know how to add 16 and 9. You understand? I don't want the final answer. The idea is how did I reach that? Similar proof. Correct? Now can you tell me how many squares are there on the chessboard? 64. Whatever that number is, 1 square plus 2 square plus 3 square plus etc. up to 8. I don't want to know what the final answer is because if you tell me I don't know. I don't know. I think 204 or 6 or something like that. I don't remember, but it doesn't matter. Did you understand? The final answer is not of interest to me. What is interest? I don't want to know that. I have given this talk so many places, still I can't remember the final number. That is not interesting. But in exam, unless you write final number, you will not get marks. But here in life, in mathematics, the beauty or the joy is in trying to find out a pattern there. Not giving me 5 and 204, the number was so boring. The path is what is more important. If you enjoy that path, then you are meant to do mathematics. You understood this? So since you are all in your first PUC, second PUC, I can ask general question. N by n square has how many squares in that? Yeah, 1 square plus 2 square etc. up to n square. So that means mathematical induction in the class then you should be able to prove this using induction. Right. It's an enjoyable work. I will not do it in the class. Now, is that clear? Sure? Now, as I said, I cannot leave it. I mean, this I have done everything. Now, what is there for you to do? I will ask every puzzle of mine will come with homework, which I won't be there to check. You want, you have to, I am giving my email address, you can check with me or you can check with your teachers. Or of course, these are Sarvagna in your pocket. Correct? So you check with him or her or whatever. How many rectangles are there? No, I will not take an answer now. You go home and work it out. Use these techniques. You go home and check. Don't do it now. You understand the question now? Go home and do it. Because if you start doing that now, it will take a lot of time and energy now. This is the problem in my class. I tell you, please don't do this problem now. I want to do it right now. Please do it at home and give me the formula if you can. Figure out 5 by 5 square, how many rectangles are there? Okay? Go home and do it. Don't do it now. I won't take an answer because if I start taking answer, we'll end up spending a lot of time. So you have to do a similar thing. 1 by 2, how many are there? 2 by 1, how many are there? 1 by 3, how many are there? 2 by 3, like that you have to do all of them and try to get a formula. It's an interesting exercise. You write down this problem and type in Google, you will get the solution. But as I told, final answer of the final solution is boring. Who wants to see that formula? The idea is, can I explore this? That's what you would want you to do. Now, why only square? I learned many other things. I do the same thing here. How many equivalent triangles are there? Sorry, I should be careful. No, don't bother. I will be aware of it now. Then continue to do See, if I tell you the equilateral triangle, you will scold me, but we all know I am talking about equilateral triangle. The procedure is the same. The new line must always be parallel to this. If I tell this is parallel to this, you will laugh at me, but it's okay. We understand it is parallel. Count how many triangles are there. Can you give me a formula? Procedure is the same. Do you understand? Yeah? This is a bit more complicated. Try it at home. If you have not understood question, we will discuss. If you have understood the question, please do it at home. Your teachers are there. Inquire with them. Solve it together. Do you understand what I am saying? Are you sure? This is a bit more. It's not as straightforward as. It's not as straightforward as the square problem, but it's not very different. How many are there? I want you to give me a general formula when I break this up into n parts. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಪ್ರಶ್ನೆ ಅರ್ಥ ಆಯ್ತಾ ಇದ್ರಿಗೂ? ಇದು ನೀವು ಮನೆಗೆ ಹೋಗಿ ಮಾಡಿ, ಯಾರು ಬೇಡ ಅಂತ. You discuss with your teachers, find out from Google. Nothing happens, you can send me your email, no problem. Do you understand this? Sure? I erase this. I will not take any answer for this now, but I expounded on a technique how to attack these problems. This is what counting square problem is. You understand? So this is a different kind of question. I have tried to collect different kinds of questions here. Some are easy, some are difficult, some will make you go through things, some you may not be able to answer. It may take you 3 months. But you must do it, not search out on the Google. Let me ask the following question. I have you know what is a spring bar? Not spring bar. What is it called? Takri. Pan. Yeah. Pan. Two pan balance. I have 24 kgs of sugar with me. Okay. And I don't have the measures. That means today when I came to shop, somehow I have not brought 1 kg, 2 kg, 3 kg, all the 1 kg, 2 kg, but 2. I have not brought it. Somebody comes and asks me, they want 24 kg of sugar. Can I give them without battu? I have 24 kg of sugar. Can I give or not?
Yes.
Then just give her 24 kg. Correct? Sure? You understand this? Yeah? Now, somebody comes and asks me, they want 9 kg of sugar. I have 24 kg of sugar. Can I give 9 kg of sugar? I don't have 1 kg, 2 kg, 3 kg, 4 kg, 5 kg, 6 kg or any kg but I don't have those measures with me. I have only a balance. Can I give 9 kg of sugar using the fact that I know I have 24 kg of sugar? 8 parts. And then 8 equal parts. How am I going to do it? I have only 2 pans. Yes.
Then again, out of that half, you divide it again by 2.
You understand this? Yeah. 12 kg, I put some approximately half into one pan, other half into other pan, and then adjust it so that it becomes half. So each one is how much? Can I make it into 6? Can I make it into 3?
Yes.
So you know this kind of thing. This is not very difficult problem. This is also a very simple question. You know milk measure problem, where I'm a milkman and I have a lot of milk in my own milk, full of milk, lot of big vessel, I have a lot of milk. And somebody comes and asks, I want 1 liter of milk, I will give 1 liter of milk. I have a 1 liter can. Somebody comes and asks for 2 liter, I have a 2 liter can, I give. So one day I came to my shop and I forgot my 1 liter can. I brought 2 liter and 5 liter can. Okay. Somebody comes and asks me, give me 2 liters of milk. Can I give 2 liters of milk? Yes. I just try to dip my 2 liter can and give it to that person. That person asks, give me 4 liter can. Twice a day. That person asks, I want 5 liters. I have a 5 liter can. No problem. That person asks, I want 1 liter. Very good. Now I go to a shop and he tells this is 2 liters, I give you half. You agree to that? 2 liters half, exactly half. How do you know? You need 2 more drops extra. What should I give you 2 more drops? How do you make it into half? Will you agree to that? Approximately half? No. That is the correct. You must see these kind of things. What you will do is, you won't take 2 times. You will take 1 5 times and put it into 2 liter can. This is 5 liter can, this is 2 liter can. 2 liter can is empty. I will dip my 5 liter can and take it out and pour it into 2 liter can. How much can I pour? 2 liters. How much is left? 3 liters. I will pour this back. How much is left?
1 liter.
Right? You understand this? If I can give 1 liter, I can give any liters, not half a liter. Again, there will be problems. Correct? If I give 1 liter, I can give 7 liters, 6 liters, lots of things I can do. You can write it in different ways also. Correct? Now, I have a 3 liter and a 5 liter can. Can I give 1 liter? This means no. This means no. What does it mean?
No.
It is not possible. You see, you are making a very strong statement. It is not possible for you or it is not possible for anybody. In mathematics, when you say no, it means not I don't know, nobody can do it. Correct? It is possible? Possible? Oh. 3 liter 2 times. Correct. So what you are telling is 1 is equal to 2 into 3 minus 1 into 5. Correct? 1 is equal to 2 into 3 minus 1 into 5. Must have seen such things, no? Anyway, I will tell you some more. I have a 3 liter and a 6 liter can. Can I give 1 liter? Can I give 2 liters? Can I give 1, or if I can give 1 liter, then I can give 2 liters also. So repeat the same process again. So try to think 3 and 6 I have. Okay, I'll make your life easier. Shall I? Yeah? Instead of 3 and 6, I have 2 and 4. Means I have 2 liter can and a 4 liter can. Can I give 1 liter for this? How do you know? Well, last time she said no for the other one, but later on she said oh, no, sorry, it's possible. Right? I think I'm hearing correct words. Yeah. Correct. Can you elaborate? I act as if I haven't heard, but I always, my ears are sharp to know what he's saying is correct. That's the mathematics behind this problem. How do I show? I cannot give 1 liter can out of 2 and 4. Yeah. Highest common factor of 2 and 4 is 2. That's correct. So what? Why? Some such theorem is there. Why? The LCM is 4, so only 4 later is possible. Do you agree to that? No, why should I agree to LCM? But you are correct. That's the crux. You must have known. You are all past first PUC. You must have known this result. No? GCD can be expressed as sum of linear combination of the two numbers of which it is GCD. No? Not heard of this? GCD means, sorry, you are language something. HCF. I say GCD, greatest common divisor. You say HCF, highest common factor. Both are same. You can always write HCF. That's what you told. GCD is the smallest unit. Which, okay, for 2 and 4 it's very easy. 2x times 2 plus y times 4. You want it to be equal to 1. Plus or minus, x will be negative. You are not scared of that, no? You see, this is even. This is also even. This is odd. You can't have even plus even as odd. So I have proved you cannot give 1 liter. Not understanding? Some number of 2 liters and some number of 4 liters is still all even only. And if you subtract or add even, you will always get even. Easy proofs. I will not write down all the proofs. This is the first step to proving GCD kind of. Go home and do it. Okay? I will not waste my time, spend more time on it. It's a very elementary person. You should, I don't know, I thought you would have, at least some of you will have heard. But anyway, you give answers, these are wonderful games. You know game games? Is this okay what I am doing? Please give me a feedback. You want something else? Ask me. What I will do is, till what time is my time? 12:30. Wow, it's over. Is it 12? I thought I will give you some time to ask me questions. I will continue with
Another 15 minutes.
Okay. So, there are so many wonderful things to do. I don't know what to do, what not to do. I will ask, well, this is a puzzle which a lot of people have liked. So, I will tell you this puzzle first before I go to game games. Okay? So, let's go over carefully. A story first. So, there is this king, Maharaja. He has, of course, a beautiful daughter. She is sort of, eligible to be married at that age. So, of course, a lot of princesses in the world want to marry her. But of course, king is khatarnak. He doesn't want to part with her daughter. So, anybody comes to marry his daughter, he cuts off their head. Sad story. But of course, she's so beautiful that doesn't prevent other princesses from trying to get her hand. So, many people try, and as usual, king catches hold of them and does the appropriate. 3 of them are popular. 3 have come to marry her, and he catches all 3 of them and brings them to the asthana. One of them, our princess has lost her heart. She wants to marry him. But now you tell king is going to kill him off first. So what to do? She thinks for some time. She tells Appa, this can't go on forever in life. I have to marry somebody sometime. So what we will do is, we will pose a challenge. We will pose a challenge. I will ask a question. Of course, king has trained his daughter to be a very good mathematician. She is very good in mathematics. So she tells, I will ask each of them one question. If any one of them answer it wrong, we will cut off everybody's head. And if any one of them answers it correctly, then I will marry that person. So king waits for some time and he thinks, he says, okay, of course she guarantees that I'll not ask her what is 2 plus 2. That's not a question whose answer will give you a princess in your life, correct? So it's going to be a reasonably complicated question. So king thinks for some time. So these 3, if any one of them give a wrong answer, everybody's head is gone. So he agrees to it. He says, okay, then I do this. That any one person who gives wrong answer, we kill off everybody. And if any one person gives correct answer, then we will marry that person. No problem. And the other 2 will be let off. Okay? So princess says, let us enact the following drama. Okay. So we are all invited for the drama. It's happening in the court. We are all invited. We are all sitting in the asana. So we can see everything that is happening. Okay. Don't be under the illusion you are neither the prince nor the princess. So the problem is not for you. Okay. We are all only observers. Understand that point. Now all 3 princes are brought here to the court. So they are standing. Prince number 1, to whom she has lost her heart to, she makes him stand here. And prince number 2 is to stand next to him. Prince number 3 stand next to him. So all 3 of them are standing in a line. Understand, mathematics is there. Line, and all is important. So please carefully follow my words. Not trick. I am not doing any trick with my words. This is not that kind of question. This is a logical question. So prince number 1 is standing here. Prince number 2 is standing here. Prince number 3 is standing here. Now the princess goes out and brings 5 crowns. Kirita. 5 of them. Out of which 3 of them are gold and 2 of them are silver. You understand? 3 gold crowns and 2 silver crowns she brings in. And then she tells, of course these 3 have seen. We have no problem, we are seeing everything. We are sitting there in the gallery. We are seeing everything. And then she tells blindfold all 3 of them. So of course king is over enthusiastic, so he gets makes sure that it is tightly blindfold. There is no hope they can see anything. You understand? Prince number 1 blindfold. Prince number 2 blindfold. Prince number 3 blindfold. All 3 are blindfold. Now she puts 1 kirita on each of their heads. Do we know what she is putting? We know because we are sitting there. So we know what is the kirita on the prince number 1's head, prince number 2's head, prince number 3's head. We know what crowns they are wearing. How many kiritas are left now? 2. She throws them away. We know what are being thrown out. Because we know, we can see what are the crowns which are on each person's head. It's thrown out. Oh. Now she tells, right turn to all 3 of them. So prince number 1 has to turn this way. Prince number 2 has turned this way. Prince number 3 has turned this way. You understand? Sure? Do they know what kirita they have on their heads? We know it. Now she tells, remove the blindfolds. So they remove the blindfold. First for the 3rd guy, and then for the 2nd guy, and then for the 1st guy. All 3 blindfolds removed. You understand? What can the 3rd guy see? Second. He can see both. He can see both 1st and the 2nd. Okay? And the 2nd guy? First. Only 1st. And the 1st guy? Can't say any. Some gocha here, sir. She wanted to marry this person and she made sure he can't see anything. Now obvious question. She will come and ask the 3rd person. We all know what is there on everybody's head. I have not yet told you, but we know it. She asked the 3rd person, do you know what crown do you have on your head? Now, his choice is he can either guess or tell the truth. Means whatever he knows. If he guesses, there is 50% chance that everybody's head will go off. Remember, if you tell the wrong thing, everybody's head is, there is no scope for anyone else to answer. Correct? So, of course, these princes are also mathematicians, so they know logic well. So she is very carefully framed her words. Any one person answers correctly, I'll marry that person. Any one person answers wrong, everybody's head will go. So if I am the third person, my duty is to make sure I don't tell a wrong answer. Correct? If I tell a wrong answer, my head will cut off. Everybody's head will get cut off. Now my life or prince, whom do I want? So I have to save my life first. So he can see both in front. And he thinks for some time and says, no, I can't tell what is on my head. It's the truth. But doesn't get him the princess. The second one, she asked the same question. Can you tell me what crown is there on your head? There could be two unequal checks. No, she is expecting me. I can see only one and thinks for some time and says, no, I can't tell. Then she asked the prince in the right in the first place, whom she had lost her heart to. She asked him, can you tell me what's the crown on your head? He thinks for some time and tells, yes, I can tell. And he tells correctly. Is this possible? Be careful before you say no. Yes? What will his answer be? Gold. Okay. I will give you a hint. Yes, it is correct. He can deduce that it is gold. Now you have to tell me how he deduced it. Remember, wrong deduction will not get cut by 2 marks, will not get cut. It's the head which will get cut. So remember this. Now you can talk for 5 minutes. You can discuss. Is the problem clear? We all know the meaning what they have to decide. Louder. So,
This is good.
Silver, no?
Yes, sir.
That logic is correct. Second year I said silver. So second year, that logic is correct. Second year I got silver and India got the princess. No, this is a logical question. They don't take the word in. Louder.
If given the two crowns are thrown means one gold will be remaining.
Louder.
Two gold crowns are thrown means one will be remaining. That may be first.
No. What ಇದ್ದಿದ್ದು ಕನ್ನಡ is okay with everybody? ಒಟ್ಟು ಇದ್ದಿದ್ದು 3 ಚಿನ್ನದ ಕಿರೀಟ 2 ಬೆಳ್ಳಿ ಕಿರೀಟ. ಕರೆಕ್ಟಾ? ಇವನು ಮೂರನೇವನು ಏನ್ ಹೇಳ್ದ? ಹಂಗಂದ್ರೆ ಅರ್ಥ ಏನು? That's the first conclusion. ಇವನು ರಾಜ್ಕುಮಾರಿ ಇವನನ್ನ ಏನ್ ಕೇಳಿದ್ರು? ಸಲ ಮೇಲೆ ಯಾವ ತರ ಕಿರೀಟ ಇದೆ ಅಂತ ಕೇಳಿದ್ರು. ಇವನ್ಗೆ 2 ಕಾಣಿಸ್ತಾ ಇದೆ, ಆದ್ರೂ ಇವನೇನ್ ಹೇಳ್ದ? ಗೊತ್ತಿಲ್ಲ ಅಂತ. ಹಂಗಂದ್ರೆ ಅರ್ಥ ಏನು? ಯಾಕೆಂದ್ರೆ ಅವ್ರಿಗೆ ಏನ್ ಗೊತ್ತಿತ್ತು? 2 ಬೆಳ್ಳಿ 3 ಚಿನ್ನ. ಇದು ಕನ್ನಡ ಓಕೆ? ಎವ್ರಿಬಡಿ? 2 ಬೆಳ್ಳಿ 3 ಚಿನ್ನ ಇತ್ತು ಒಟ್ಟು ಬಂದಾಗ ಒಳಕ್ಕೆ. ಅವನು ಮುಂದೆ 2 ಬೆಳ್ಳಿ ಕಂಡಿದ್ದಿದ್ರೆ ಇವನೇನ್ ಹೇಳ್ತಿದ್ದ? You would have got the princess. But what did he say? Gottilla. That means what?
Both of them will have different.
One gold, one silver. One gold and one silver.
Did he say that?
No, he might have been seeing one gold and one silver and have a confusion like which one might be on his head.
Isn't that he will see only one gold and one silver?
Gold and silver.
That is what he has to be clear about.
Both
ಎರಡು ಬೆಳ್ಳಿ ಆಗಿರಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ನೀವು ಒಂದು ಗೋಲ್ಡ್ ಒಂದು ಸಿಲ್ವರ್ ಒಂದು ಹಾಕ್ಬೋದು.
Because you've said at the end that he has got gold. First one has got gold.
No, that is you have to give that first one is reducing that. It is later. I am telling now from this perspective. First one doesn't know anything right in the beginning. Does he know I have gold? He doesn't know. How does he know? No way. Please follow the logic. The third guy, what has he seen or what has he not seen?
He has seen the other two scrum but not this one.
Correct. But what can he deduce from the other two? For example, what can the second guy deduce from what he says? That both these are not silver. He can't be sure it is gold. Alva? ಎರಡು ಸಿಲ್ವರ್ ಅಲ್ಲ ಅಂತ both of them know. Correct? Do you understand this? Yes. Mathematics is very important. Language is very important. That's why I have chosen this person. What he is telling is, when he says I don't know, he is telling them, what is he telling? What is he telling?
Both are not similar.
ಹಂಗೆ ಹೇಳ್ತಾ ಇಲ್ಲ ಅವನು, ಅದನ್ನ ಇನ್ನೊಂದು ತರ ಹೇಳ್ತೀನಿ. Yes, I can see a gold. I can see at least one gold. He can't say I am seeing one gold. Both may be gold. Correct? He is saying I can see at least one gold. Because everybody wants to save their life now. So he is telling I can see at least one gold. So these two guys understood that this guy has not been able to tell means both of us are not wearing silver. One of us is wearing gold. That much is concluded. Sure, you can't say he is wearing gold, he is wearing silver, he is wearing gold, he is wearing gold, he is wearing gold, he is wearing silver. All ಗೊತ್ತಿಲ್ಲ. ಅಷ್ಟೊಂದೇ ಹೇಳಿದ್ರೆ ರಾಜ ಅಲ್ಲೇ ಹೋಗ್ತಾರೆ. Just telling I don't know. Other thing he is telling me I know. But these two guys and that girl knew that they are all mathematicians. They can deduce. So what have they deduced? His statement of saying I don't know is equivalent to saying one of you is wearing a gold. That's a very strong information. Correct? Now let us analyze the second thing. Now that guy is telling he can see a gold. That means either I must be having gold or he must be having gold or both must be having gold. Correct? Now, if the first guy had silver on his head, what can the second guy say? Gold. Because he knows that guy is seeing a gold and I am not seeing a gold, so it must be gold. But he says, I don't know. That means what? I am not seeing a silver. That means he said, I am also seeing a gold. I don't know what's on my head. Because if he had seen a silver, he would have immediately got the princess, no? So Rajkumari was very intelligent. She put gold on him. You don't care what he put on second one. Correct? Only both should not be silver, that's all. Because then she would have to marry the third one. Correct? So she put gold here. And this, he couldn't see any, but he could deduce. The first guy is telling, I can see a gold. Second guy is saying, idiot, I can also see a gold. And then this guy, I have a gold. Correct? Do you understand this logic? It's a very beautiful logic according to me. But initially, one would think the guy at the back has all the advantage because he can see two of them. But that is useless here. This guy couldn't see any, but he had two information. You see how much more important information is than actual thing. This guy could see two things, but he had no information. The first guy couldn't see any, but he had two pieces of information from which he could conclude. I will do one thing. There is no exercise here, I explained everything. So I will ask a question and leave it. You please go home and figure out. Okay? It's a very famous question called Lady or the Tiger. There is a similar instance where there is a king and of course he has a beautiful daughter. And then of course there are people who want to marry her. And there is one such princess come here. And here king himself is posing the question. It's like the king has said, I want the best brain. So he said, I will ask the question. What is the question? Here is the question. There are two rooms. Both the rooms have a door each. Okay? In one room, there is his daughter sitting. And in the other room, there is a tiger. You choose whichever door you want. You choose the door with my daughter, you get my daughter, you marry and go. You choose the door which has tiger, you get eaten up by the tiger. The choice is yours. So of course many princes would be taken up. It's a 50-50 chance. There is no information. No, that's not mathematics. So king said, okay, I will help you by giving you hints. Which door, behind which door is my daughter, I will tell you. How will I tell you? There are two watchmen to both the doors. And there is one watchman to this door, there is one watchman to this door. You understand this?
Yes.
And both the watchmen know behind their door is who is there behind their door. Both of them know correctly. Okay? You can ask any one of them one question. You can ask second question. You can ask both of them. You can ask any one of them one question. Okay? Any one question. And you find out behind which door is the lady. But there is a twist. One of the watchmen will always tell a lie. And the other one will always tell the truth. I don't know who tells truth, who tells lies. Obviously, otherwise there is no question. Correct? One of the watchmen will always tell a lie. Another watchman will always tell the truth. I have to ask one question to any one of them and find out behind which door is my princess. Is this possible to answer this question or not? Should be possible, otherwise I would have asked. That's a good logical debate. Now can you tell me the question? 1 minute, that's what I told you. You know the answer before? Oh, you are trying it out the first time? Go ahead. Okay, 1 minute. Let us enact. Do I have time for completing this? So, his question is, tell me behind which door is princess not there? So you ask me, I am another watchman. I show you this door. Then what do you do? I show you, this is the door behind which princess is not there. What will you do? I do not know that. Do you know I am either a truthful guy or a liar? You don't know. Do you understand the question? Please, 1 minute. Yeah. You are asking me. Yeah, I am one of the watchmen here. So you are asking me. Yeah, you are asking me. So he is asking me, are you the watchman for the princess? I say yes. Why? What watchman do they make? I am a watchman anyway. But you are asking whether I am watching the girl or the tiger, right? Okay, I will tell yes I am. Then what do you do? Okay, now you know I tell That is even simpler. You can ask what is 2 plus 2. So if that guy says 4 is a truth guy. If he says something other than 4 is a liar. Okay, now what? If you get the princess, your idea was to get the princess or find out from the watch for you. You understand? That's the first correct wrong step. The idea, remember, is not to find out who is telling truth, who is telling lie. So what do I do with that information? If you are questioning, you are trying to find out who is telling truth, who is telling lie. You are lost the game. You are not come to find out who is telling truth. What have you come to find out? So keep that in mind. So I will not waste your time, but initial questions I have to take because I wanted to make you understand the complication of the problem. So you go home and think. You can send me the answer. There is a very famous book called The Lady or the Tiger. It's by Smullyan. What's Smullyan? Richard Smullyan, I think. I'm not sure of his first name. Smullyan. It's freely downloadable book. Recently, 2-3 years ago, he passed away. He is one of the greatest puzzle makers. Lady or the Tiger is the title of the book. If you just type Lady or the Tiger, Google will show you where that book is. It has many such puzzles which I told you just now. Here are 2 of the selections I have taken from that book. Try going through this book. It will really make your lots of logical puzzles are there. This is a very famous example for what is known as logical filter. There is one truth guy and there is liar. I don't want to know who is true, who is telling truth, who is telling lie. I want to know behind which door is the princess. So you have to be clear about your objective. Nimge geometry na barstidralva to prove that. First you will be clear about what is it that you want to do. If you don't know, you will get lost. You understand? So the objective must be very clear. 27. I have just 3 minutes. 15.
Oh, 45.
Oh, okay. No, I can go on for more time. I just don't want you people to be tired. So should I give some time for questions or it's up to you?
As the wish.
It's up to you. If you have questions regarding your class 11, 12 maths or careers in maths or research. Maths research means this kind of thing. You should be able to enjoy logical constructs. You should be able to count correctly. Patterns, deduction, I told you, no. They are the heart of mathematics. If you like doing it, you are welcome to do mathematics. Any particular question you have or even general question, please feel free to shoot. Any question regarding career or anything, I don't know. Or any particular doubt you have in maths or particular concept you want to understand, please feel free. Any questions regarding anything? I want you to understand the beauty involved in mathematics. Mathematics is not a dry subject. It's a very organic subject. It's a very live subject where you need to be participating. It's not some theorem, and rules and formula. They are the boring part of mathematics. The beautiful part of mathematics is what you explore. These are some of the problems. I left many other problems in the PPT. You can take it. No problem. These are problems which you need to explore. You understand what does it mean? Explore means you have to try to get the answer. That is where maja is. That's when you will feel, nice. Let me see. Here is one thing I can do. Okay. So we do some simple, very easy pattern kind of thing. This number 10810 is, let us check. No problem. So do what is told there. Pick any three, all of you, in your paper, in your book. Write a three-digit number which is not a palindrome. Palindrome andre gotta? For example,
1 to 1.
1 0 3 digit. So pick any number which is not a palindrome, 3-digit number. Pick, write it. And similarly, ಬೇರೆ ಬೇರೆ ಇತ್ತು ಆ ತರದ್ದು ಯಾವ್ದಾದ್ರು ಒಂದು 3-digit ನಂಬರ್ ಬರೀರಿ. ಡಿಫ್ರೆಂಟ್ ಪ್ರೊಫೈಲ್ ನೀವು ಬರೆಯಂಗಿಲ್ಲ 3 to 1 ಇದೆಲ್ಲ ಬೇರೆ ಬೇರೆ ಬರೀಬೇಕು.
Find the difference.
So for example, 751. If I have done this, I will write 157. This is the reverse. Correct? Find the difference of this. Right? You done? So let me do it here. No, I will not do it. That I will do it in that. Have you done it? Everybody must do it correctly. You get an answer? Yeah? Take its reverse. For example, here
594.
So now I will reverse this. 495. You understand? I'll add that.
089.
Yeah, you start. 108. You have done it correctly. And 1089 is a very beautifully symmetric pattern. Lovely patterns are there. I'll just show you some of the patterns here. Very beautiful. Can you see that? Calculate there. ಮಾಡಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಇದ್ರೆ ಮಾಡಿ. ಪ್ಯಾಟರ್ನ್ ತೋರಿಸ್ತಾ ಇದೆಯಾ? ನೋಡಿ 1 2 3 4 5. What should be the next one?
6
And similarly second digit.
7
Third digit.
76.
Fourth digit.
8672.
998 10 890.
See the pattern? Yeah. First digit is increasing. Second digits are increasing. Third digit is decreasing. Fourth digit is also increasing. Not just that. You see this 1089 into 1 is 1089. 1089 into 9 is 980. The reverse. The first and last are reversal of each other. Second and second last are reversal of each other. third last the reversal of feature. Fourth last the reversal of feature. Fifth one is palindrome. Understand this? Can you think of a reason why does this happen for 1089? Can you think of one more number like that?
9.
Aste alla 1089 is 33 square. It is sorry. Something wrong. Okay. It is 1089 is 33 square, which is also equal to 65 square minus 56 square. They are reversal of each other. Their calculator you can verify here right now. Otherwise, the computer is there, so you can always 1089 has lot of beautiful symmetric properties like this. Why does this happen? You take any integer. For example, I'll show. Do I have time to show this? Since they are not asking questions, can I go ahead and show this? Tell me any number. 4, 8, 0, 9. Now you take 4 square plus 8 square plus 0 square plus 9 square. You have to compute that. You will get something. Take its digits. Take the squares of it. Add them.
161.
How much?
161.
161. This is 161. So write 1 square plus 6 square plus 1 square.
38.
38. 3 square plus 8 square.
73.
Keep on doing this. 7 square plus 3 square.
58.
58. 5 square plus 8 square.
89.
There is 89. 8 square plus 9 square.
145.
1 square plus 4 square plus 5 square.
42.
4 square plus 2 square.
25.
3 square plus 5 square.
So 25.
Is 25. So 2 square plus 5 square.
29.
9 square, 2 square plus 9 square.
121.
8 square plus 5 square.
85.
Keep on doing this, you will some stage come back to 89. So it will be a loop. You have to do a lot of times.
So 4 square plus 4
I
square.
might have made a mistake, but you understand what to do?
20, sir.
Yeah? Go home and do this. Take any, start with any number. Take its digits, square them, add them. Keep on doing this process. You will always end up with 1, 0 or 89. 0 means 0 only. Otherwise you will end up with 1 or 89. Always. So this is one more of the, 1089 is like an attractor. Means it attracts lots of things. I have already shown you several things. This is one more such thing. Here, this is another beautiful pattern. 1089 into 9 is that. You can check with your calculator. 10 in between 0 and 8 I will introduce a 9. You understand what I am doing? Between 0 and 8 I am introducing a 9. Then between 8 and 0 I have introduced a 9. You can check the pattern. Introduce 2 9s, then I will introduce 2 9s. 3 9s, 3 9s. This will go on. My question is, you have to figure out why does 1089 behave like this. I showed you several symmetries of 1089. What is beautiful about it? Before you type 1089 in Google, just spend some time. You type 1089, there is a book written on 1089. Just this number. There are so many beautiful symmetries around it. I have shown you a few of them. There are more advanced symmetries. I won't bother about that. I think perhaps I should stop here now. I still have 5 minutes. So let us check quickly if I have something which I can do in 5 minutes. Calendar magic. Do you have a calendar here? No. doesn't matter. Okay, you see, in calendar, okay, I'll let the cat out quickly. So, calendar, don't throw out whole calendars. Lot of beautiful mathematics can be done in that. You pick and choose any calendar. So it will be something you later know 1, 2, 3, 4, 5, 6, 7. Correct? And then 8 will come here. Correct? 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. I've written down several symmetries. What I want you to observe, I'm going to the final answer first. Normally I don't like to do it, but lack of time, so I'm telling you. You see, these are arithmetic progression with common difference 7. These are arithmetic progression with common difference 1. Correct? Both are coming together. There are lots of nice things which happen here. For example, you take any 2 by 2 square. You understand that? You add these two and add these two. What will we say? Any 2 by 2 square. Why does it happen like that? Same arithmetic progression. Because if this is x plus 1, this is x plus 7, this is x plus 8, this is 2x plus 8, this is also 2x plus 8. You understand what I am saying? This is a very basic thing. Calendar is a lovely thing which you can do lot of mathematics, lot of beautiful symmetry. For example, you see here, this is 1, 2, 3, 4, 5, 6, 7. This number is average of every number here. If you average of this whole column is 4. Why? Because 1 plus 7, 2 plus 6, 3 plus 5. All of them are 8. Correct? You have to divide by 2. You understand? You have to exploit all this. Try doing what happens to a 3 by 3 square. There are many beautiful properties. Add these two. See, this is the average of that. These two, this is the average of that. Whichever way you take, this is the average of this. When said like this, it sounds funny. But you try to explore calendar. It's very beautiful grid. Because one basic idea is, like I don't have time, so I'm not doing it. I'm giving you the answer. The basic idea is this. Row wise, it is an arithmetic progression with common difference 7. And column wise, it is an arithmetic progression with common difference 1. You understand? So a lot of calendar mathematics can be done. Just type calendar mathematics, you will find lot. Not what I started with. Mathematics of calendar is different. I started in the beginning, right? How calendar is made. That is different. This is after calendar has been made, what I can do with it. That's this story. Many things I will not. So these are all questions which will interest. This will all be questions which will involve your AP, not GP, APs. You have done AP, no? Somewhere you must have done. So many things I don't think I'll have time to do all these things. I'll stop here. I thank the organizers for having given me this opportunity.